All right, let's read our scenario. Chapter 6, team test. This is actually a problem from the 2009 AP exam. The storm washed away sand from a beach, causing the edge of the water to get closer to a nearby road. The rate. Okay, as soon as I read the word rate, I'm going to circle it. The rate at which the distance between the road and the edge of the water was changing during the storm is modeled by f of t equals in meters per hour, t hours after the storm began. The edge of the water was 35 meters from the road when the storm began, and the storm lasted 5 hours. All useful information that'll come back. The derivative of f of t is f prime of t. We could have totally derived f of t ourselves with our power rule and trig derivatives and been just fine. Let's go ahead and look at A. So my point in making this video is we'll go through the whole thing. Anytime I answer a question on these things, I'm really not answering a question. I'm just reading words with you and encouraging you to use the words in the right way. What was the distance between the road and the edge of the storm at the end of the storm? So as I was walking around watching, we know it was 35 and that it was changing. And it was changing at the rate of f of t. So if I add up all of the changes from 0 to 5, because the storm lasted 5 hours of f of t, it should tell me exactly where we're at. So if I put f of t into my calculator, again, calculator active, you'll never get a question that says square root of t plus cosine t minus 3 and have to do anything by hand with that. Go ahead, plug it in. I think it ends up being negative 8.505. And so when we add those up, we get 26.495 feet. Does that make sense in our scenario? Sure. They love these questions in B. Using correct units, interpret the value of f prime of 4 equals 1.007 in terms of the distance between the road and the edge of the water. So the derivative of the rate is positive 1.007. So here's the explanation. The rate of the decrease for the road to the sand, edge of the water, is increasing. It's a positive number. If a decrease was decreasing, the rate would be getting bigger. But because a decrease is increasing, the change in distance is decreasing. And drawing the arrows that the decrease is increasing should help you understand why the change in distance, which is this is the change of that, is decreasing. The derivative is positive, but the function was decreasing with a positive derivative, meaning the change in distance is decreasing. Part C, at what time during the 5-hour storm was the distance between the road and the edge of the water decreasing most rapidly? So f of t is what we want, because that is the rate at which the distance is changing. So when was that change the largest? We would take, to find the maximum of f of t, we want to know when f of prime of t is equal to 0 to find our extrema. So if I find my zeros, when I plug that into my calculator, calculator active, use your calculator, we get two critical values, 0.662 and 2.840. And we'll plug both of those numbers into our f. F of 0.662 is negative 1.397. F of 2.840 is negative 2.26, meaning this is the larger decrease. So at time 2.840 is when we are decreasing most rapidly. Now, we need to also look at our two endpoints. Check f of 0, it's decreasing at a rate of negative 2. And check f of 5, it's decreasing at a rate of negative 0.480. So good justification, checked our endpoints, checked our extrema. We are decreasing most rapidly at a time of 2.840. Part D. After the storm, a machine pumped sand back onto the beach so that the distance between the road and the edge of the water was growing at a rate of G of P meters per day, where P is the number of days since the pumping began. So we've got this G of P in terms of days. Write an equation involving an integral expression whose solution would give the number of days the sand must be pumped to restore the original distance between the road and the edge of the water. So what does that have to equal? It has to equal how much we decreased. And we know that we decreased 0 to 5 of f of t dt. That is how much the distance has changed. That was our original rate of which the distance between the road and the edge of the water was changing. So if we add up all of that change, that tells us our cumulative change. We need the integral from 0 to x of g of p dp to be equal to that. If we add up all of this rate, once it equals how much we lost, we're good to go.